So now we're going to talk about those transition elements. Transition elements, we call them multivalent. Multivalent means they can have more than one oxidation number. We see that with the transition elements and then tin and lead in the carbon family. Remember a while ago it could be a 4 or a 2, so tin and lead. So we see it with most of your transition elements, except for silver. Silver is always a 1. Okay, and I wrote that in there. Some elements have more than one oxidation and need a Roman numeral as part of their name to tell the oxidation number. These are most of the transition elements, except for silver is always a positive 1. Zinc is always a positive 2. Cadmium is a positive 2. And I wrote that on your periodic table. And then tin and lead also need Roman numerals when we name them. Okay. So I've got a couple examples here. So copper, and this is already written, we've already changed the ending, so this is already proper form. So copper on the periodic table is in the transition elements, and it says needs a Roman numeral. Well, it needs a Roman numeral, so this is not how many coppers. Please know that this is not the number of coppers, not the number of leads. This is the charge. When you see a Roman numeral, it is the charge of that metal. So this is a 1 positive charge. I'd go to the periodic table and chloride is a 1 minus charge. So the formula for copper 1 ion, 1 and 1 cancel, is CuCl. That is copper Roman numeral 1 chloride. That's how we name it. Copper Roman numeral 1 chloride. So it's kind of like the formal name. Notice I don't have a Roman numeral in the formula. It's in the formal name. Just like some of you may be a first or a second or something in your name, you don't show up until you have the formal name. So the formal name, copper 1 chloride. Well, this is copper 2 chloride, so this is telling me to use that as a 2 plus. Watch when I write the formula. You're not going to have 2 coppers. Okay, so the common denominator, if you like that, would be 2. 2 would go into it 1 time, 1 would go into 2. If you like the swap drop method, would be CuCl2. That is called copper 2 chloride. Do you have 2 coppers? No, it is telling you the charge of the copper ion. Okay, so it's the number that we switched if you want to think of it that way. The name of this one is copper 2 chloride. The name of that one is copper 1 chloride. All right, let's look here. Lead 2 oxide. So that Roman numeral, again, not how many leads. That is the charge of the lead. Oxygen on the periodic table is a 2 minus. What happens when they're the same charge? When they're the same charge, they cancel each other out. So you can write ones if you prefer. So it's just PbO. So this is called lead 2 oxide. Do you see any numbers? No. You don't see any numbers because they have canceled each other out. So PbO is lead 2 oxide. This is lead Roman numeral 4. If you don't know Roman numerals, you need to know at least up to 4. And so 1, of course, is that, 2 is that, 3 would just have another one, and that is 4. We're really, the transitions can actually have a 6, a 5, and a 6. We're just not really going to do any of those. But they can have more than 4. They can have a 5 and they can have a 6. So if you see a 5 and 6, don't freak out. They can have those. All right, transition elements. So this lead is a 4 positive and this oxygen is a 2 minus. If I do the algebra method, the number that they both will go into is 4. 4 will go into 4 1 time, and this will go into it 2 times. PbO2. That is the formula for lead Roman numeral 4 oxide. Isn't that strange? There's no 4 in that formula whatsoever. But again, the Roman numeral is the charge, not the number of lead ions there are. Okay. If you like the swap drop method, this is where students will make mistakes. I would put a 4 there and I would put a 2 there. So I would get PbO4. If you left it like this, it would be counted wrong because this now is a 2 and a 4, and a 2 and a 4 reduces to a 1 and a 2. This is the correct formula. This one would be marked wrong. This, you would get no credit for that whatsoever, because you have to reduce. So swap drop and reduce if you like to swap drop. See, if you do the algebra method, you get that formula anyway. It's because I need, this guy's trying to give away 4 of his electrons, but oxygen only wants to take 2 of them. So I'm going to need 2 oxygens to take on the 4 electrons that lead is giving away. So that's why it's PB. Remember the ratio. So back when I did that NaCl earlier, it's the smallest ratio of the numbers of atoms.